Okay, so we were looking for the variance, a confidence interval around the variance. And so what I've done is I've written the formula we're going to use for that down here. So we're looking at the sample size n minus 1 times the sample variance divided by a chi-squared value associated with the right. This is less than the population variance, which is less than n minus 1 times the sample variance divided by the chi-squared. This should be squared, chi-squared for the left. Notice these are kind of reversed, and that's because you want your bigger chi-squared value over here. This is how you're always going to think about it. Your larger chi-squared value over here is going to result in a smaller number on the left side of this inequality sequence, and your larger chi-squared value, or your smaller chi-squared value, will end up over here, which will end up with a bigger number on this side. So this will be nested between a smaller number is less than, the variance is less than a larger number. So then it's just a matter of picking out the numbers in the problem and placing them correctly in your relationship. Here I'm just going to write some stuff here so you can let's go s squared is your variance for your sample, so your sample variance. N is your sample size. Notice that the degrees of freedom is 1 less than your sample size. So this is actually degrees of freedom here. And then your chi-square values you calculate based on your confidence interval when you come up with an alpha and an alpha over 2 and using the chart. So let me set up an example. Okay, I've added the problem statement. And the problem is find the 90% confidence interval for the standard deviation for the number of named storms per year in the Atlantic Basin. And I'm given a random sample over 10 years. So number of storms per year over 10 years. So the first thing we want to do, we take a peek at this. One of the first things we can do is we can calculate our variance here. So use an app to do that or calculate by hand, but come up with a value for the variance. And the variance I get is approximately 16.9. Okay, the next thing we're going to do is we want to find our chi-squared values, our right and our chi-squared left. So remember that in general this is going to be a skewed distribution. So we've got the chi-squared left and the chi-squared right. This is a 2 up here. Chi-squared left, chi-squared right. So got to come up with our alpha then. So alpha is, if we're going to do this with a 90% confidence interval, so our alpha is 0.1. So alpha over 2 is 0.05. So that's our area there. That's our area there. Of course, in here we have 90% of the data. So then our chi-squared left is going to be essentially what we're going to get for a chi-squared at 0.05. That'll give us this. And our chi-squared right is going to be our chi-squared of 0.95, because recall, the chart's only going to give us areas to the right of this, so we have to take 1. We're going to take 1 minus 0.5 to get 0.95. Okay, so let's take these values up here to our chart. Let's first do this. N equals 10 here. So our degrees of freedom equals n minus 1 equals 9. So we'll take the 0.05 and the 0.95 up to our chart and enter at a degrees of freedom of 9 on the chart. So 0.05 at 9 is 3.33, 0.05, 9, and come over here to 0.95, 16.92. So let's write these down. 3.33, 16.92. Now just a note here, you might be using an app to calculate these, so you might have more decimal places. So keep that in mind. Your answer might vary slightly than the answers in your homework problems if you're using an app, or depending on the table you're using, depending on how the homework problems were calculated. So I've gone on and paused and pasted the equation we want to use from above, so you didn't have to scroll up. And now it's just time to put in the values. So n minus 1 is 9 times our standard deviation, 16.9, divided by, and again, this is the right, so this is the bigger number, 16.92. That's less than our population variance, which is less than 9 times 16.9 divided by 3.33. So it's not much different than what we did before. The equation's a little different, but it's just plugging and chugging numbers. Okay, so then I get, if I do the math here, I end up with, I'm going to pause and do the math. Okay, I'm pausing here. You can see I've typed this into my scientific calculator here on the computer for the left side, and I get 8.98. Let's just call that 8.99 and 8.99. I did the calculation on the right side. So our variance, so we're 95% confidence. That was a confident interval, right? No, we're 90% confident. We're 90% confident our variance lies between 8.99 and 45.68. Okay, well, I asked you for the standard deviation. So what are we going to have to do? Well, for a standard deviation, we're then going to have to go and we're going to have to take the square root of all these terms. So if I go ahead and do that calculation, I will pause and do that calculation for our population standard deviation, and I did the calculation and added some text. So we're 90% confident that our population standard deviation in storms is between 3 and 6.77. And that's it. That's the solution to this problem. So you should be able to do everything now on your homework quiz. And good luck. I'm going to end this recording.